Hi everyone, this is Ileana. So I will be going over problem 2 for project 2 of the finance context. So if you haven't already, please go ahead and go watch problem 1 video, just because I'll be assuming that you have already watched that and that fundamental and base is taken care of. Um, so yeah, let's get started. So let's start off by sort of reading the question. So it says, recall the formula for computing the price CO or C0 of an option derivative of the BLM stock prices that yields payoff at time t, denoted by CT. And then we have the equation where star refers to the fact that we must use the value P star instead of the original real P for the up/down probability of the BLM. The real value of P is not needed for pricing. Also recall that CT, and then we have another equation, the European call option, the expected value, and another equation, can be computed explicitly yielding the famous Black-Scholes-Merton option pricing formula. So there's a big formula right after that, which we'll be going more in depth about. You are to use this formula to exactly obtain the price on the one hand, and then use Monte Carlo simulation on the other hand to compare and thus see how accurate the Monte Carlo method can be. So essentially what this is saying, right, is, and if you haven't read the rest of the problem, go ahead and pause the video now and read the rest of it. But essentially what a problem is saying is that we are going to be doing two different things. So there's almost going to be like two parts to it. Part A is going to be calculating, excuse my misspelling, which will probably happen pretty often. So the first part is calculating the price using the Black-Scholes formula. And the second part, which we're going to call part B, is going to be calculating the payoff price using Monte Carlo simulation. And so now what the heck do we mean by this, right? So just sort of a brief review. I'm not an econ major, so my knowledge of this is not super specific, but I do know what these formulas are for. So to start off, like an option is basically something you buy today and then you sell later on at a determined price. So this determined price, so we're going to be going over like what these variables mean, yeah? So this set price that we set is called the strike price. And the strike price is represented by K in these formulas. And so the idea is that, let's say I want to buy some Tesla stock. And I mean, obviously, if you guys follow the stock market, Tesla is extremely expensive, but let's assume that Tesla is $5. And so today, Tesla is $5, and I decide to buy it for $5, so a strike price of $5. And so what an option is I'm going to buy 10 Tesla stocks for $5 each, but I'm not going to buy them today. I'm going to buy them later on in the future, and regardless of what price they're going to be, I'm going to buy them for $5. And so when you buy an option, you're sort of buying something that you will buy later on, but you sort of set the price, which is what we call the strike price. So the risk in that is that, you know, let's say that Tesla is doing great and my strike price date is going to be in, I don't know, end of December, right? And so let's say I can assume that Amazon oh wait, I said Tesla. I can assume that like Tesla will be doing great in December, because I don't know, California is about to roll out, I'm making all this up. California is about to roll out a new law that everyone has to have electrical cars, right? So I am assuming that Tesla's going to go up than the $5 that I bought it for. Um, but it's sort of like an assumption, right? So the opposite could happen, right? And there can be another law that says that electrical cars are banned because they're actually terrible for the environment, which again, all this I'm making up, right? So the idea is that your payoff or your C of zero, so your C of, we're going to call it C of n, which is going to be the payoff that you get from doing all this, where n is a date in the future. So we're going to assume that, for example, if we say n of 1, that is going to be 1 day after I buy it, and n at 0 is going to be the payoff that I would get at the very beginning, right? Which is like, which would be 0, right? Like there's no difference if I just sell it off the same, right? Same date, right? So with that in mind, basically like I want to know how much would I be gaining or how much would I be making or losing if I were to sell this at C underscore N. So with that, there are a couple other variables that I think are very important. So the next one would be time. So the next one would be T, which is time in days for the specific problem. And so that basically means how long am I going to hold this option. Another helpful thing is S of n. So S of n is going to be the stock price at day n. And so we're going to go a little bit more depth to like what this means, but that's just like an important thing to get out of the way. Let's see. Another thing to note is that, let's see. We also have U's and D's. So we have a U value and we have a D value. And these two values are pretty similar, with the exception that U is the factor that we would multiply S by if the stock went up, and D is a factor we would multiply S by if the stock went down. So we're going to write that down. So U is the factor we would multiply S by if stock went up, and D is the same thing, but the opposite. So if the stock went down. And so what that basically means is that for example, today my stock might go up. And so I would multiply the current value of my stock times 1.15. If my stock went down, then I would multiply my current value of the stock times 1.01 to give me the new value. And so obviously, like if you multiply something by 1.01, that is not really going down, but it's not growing that much. So the reason why we didn't make this something less than 1 was because we wanted to make sure that you all had positive numbers, essentially. And so that's why we have that on there. But your U and your D could have like been anything, where it's just like U has to be bigger than D, right? Because one is up and one is down. And so yeah, that's sort of like just something to know because I know we've gotten a couple of questions about that. And lastly, we have our discount rate, where our discount rate is this little fraction that we have here. So that's 1 over 1 plus r to the t. And Yeah, so now we're gonna go over just like the general equations. So now that we've like sort of defined these, let's go over a little bit more in depth into the equations that we're giving. So if we see here, we have C of 0 is equal to the discount rate and then the summation of k to 0 to t. So if we look down here, we know that t is going to be 10. So that we know that t is going to be 10. And then here we have t choose k. So what the heck is this, right? So this, oh, so this is the binomial coefficient equation. And so I'm not going to get too in depth into what that is. Um, But essentially, we need the equation of this to be able to calculate the whole equation. So if you search up binomial coefficient equation, you are going to be getting an equation that should look like basically n factorial over k factorial times n minus k. So the difference of that factorial. Um, So I'm not going to write it on here because that is your job and I'm already giving to you. But basically, that is the binomial coefficient equation. So we are going to plug in t into that and then k. Um, and so our t for the specific example and for the parameters that we were given is always going to be 10. And our k is going to be changing, right? So it's going to be going from 0 all the way to 10, which, hint, hint, from 0 to 10, right? That sounds like some sort of loop. Um, and then from there, we have p star to the k power. And then we have 1 minus p star. So p star is going to be calculated by this part. And then we have t minus k. And the same thing, we just plug in into this. So let's go a little bit more into depth as to like what this should look like in code. So so it's going to be our part 1, right? So our part 1 is just literally going to be plugging it in to the Black-Scholes model, which is right here, and just seeing what we get from there. Yeah. So to start off, we're going to create a quick just header for our function, just to get that like out of the way, and so you don't have to struggle with that. So we're going to call that, we're going to call def, and we are going to call this Black-Scholes. And so if we look at our equation here, we have to pass in all the parameters that are needed to calculate it, right? So the first one we see here is r, so we're going to put an r in there. Then we need to pass a t, and we're going to pass a t. Then we are going to pass in our p. So p, I know we've gotten this question quite often too. For p, you can either use p star or the p that we gave you. I would lean more towards p star because it would be a little bit more accurate. So for me, I'm not going to pass in a p because I'm going to calculate it using r, d, and u. So let's pass in u and d as well. And then after that, I need an SO, so a starting stock price. So basically stock price at day 0, which again is also given through our parameters down here. And then I lastly want a K. So the strike price at which I bought this option, like the strike price, my strike price at which I would end up purchasing my options at. Okay, so now that we've covered that, basically this first part is just plug and chug type of thing. So um, if we notice here, right, we have the summation of this whole chunk. Um, and so basically inside of some sort of loop, right? Hint, 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 hint. So in some loop, I want to do everything to the left of, no, to the right of the summation. So that would include calculating the binomial coefficient for t and for t choose. So basically the way that you say this out loud is t choose k. Choose k, where k will be changing, right? So k will have to go from 0 to 10. Hint, hint for your loop. That's all I'm gonna say with that. And then after that, we're gonna have a P star. So our P star is gonna stay the same every time. So we might wanna calculate it out here. So we wanna calculate P star as well. And then after that, we wanna calculate these other chunks. So again, the rest of it is generally pretty straightforward, just like Python math type of stuff. But the thing that I want to cover is this little plus sign at the end. And so what that plus sign means is essentially what you're calculating here. So let's take a look at like the stuff that we're multiplying. So I'm going to have an up value, an up factor, a u factor, my factor u, and my factor d, right? And I am saying I'm going to take my factor u and take it to the power of k, and then I'm going to take my factor d and take it to the power of t minus k. So we're going to be multiplying our s of 0, which is our stock price at day 0, by some sort of factor, and then I'm going to be subtracting it by the strike price. So essentially what this is giving us is this is going to give us how much we, like this number essentially has to be a positive number. And the reason why it has to be a positive number is because if our stock price is not bigger, our stock price and the factor multiplication part of it is not bigger than our strike price, then we don't want to exercise our option. So what the heck does that mean? That basically means that if I am not going to get money off of this option, I don't want to sell it. And so this plus sign basically means that, so exponent plus sign means that if it is not positive, I don't want it. So what that means is that if the number that this part gives you is not positive, we are just going to assume that it is 0. So basically, if negative, then that whole thing will be 0. So I'm helping you all a lot with what all these things mean, but the code is up to you. But you want to think like, what can I do to check if this is a positive number? And if it's not a positive number, then it's something. And if it is a positive number, then it's just the value in here. So that is all I would say with this respect. And so, yeah, at the very end, you want to multiply this times the discount rate and then give your final answer for that. And this problem should give, oops, I put it in part B. So for the first part, this should give you something around around approximately like 7.9-ish. Again, just this is for like your sake, we're going to be looking at the code. The whole point of this assignment is to sort of show you all how much we can do with programming these things and how these programs can be used to simulate all these scenarios. So yeah, that is the first part. And so now we're going to go on to the second part, which is where it gets a bit tricky. So the second part says, and we're just going to reread it again, then use a Monte Carlo simulation on the other hand to compare and see how accurate Monte Carlo method can be. So what that means is that now we somehow have to adjust the Monte Carlo method to work with our equation. And so again, if you haven't already, please watch the problem 1 video. Otherwise, you will be very, very confused. What it says is for Monte Carlo, use n is equal to 100, n is equal to 1,000, n is equal to 10,000, IIED, which is independent. Let's see, I completely blanked them. Independent and identically distributed values, which like we don't really care too much about that, copies of CT. We're averaging to see how it gets more accurate as n increases. So the general idea of it is that we no longer want to use this exact equation that we were given. We now want to use some sort of estimate that involves randomization to figure out if like just randomly showing some dates will give us the right answer at the very end, right? So again, I'm gonna keep this over here and put this in part B. And so how the heck are we gonna do this? So let's like talk about it for a bit. Yeah, so in the previous problem, we used Bernoulli, right? We used a P to decide whether our random Bernoulli value was a 1 or a 0, right? But for this problem, we are not that concerned with 1s and 0s, right? We are more concerned with something else. And that something else is whether the stock goes up or down. So if I simulate 100 million 100 million days in the stock market, yeah, and I simulate these 100 million days and I have a p-value. So in this case, for part B, we can use, again, a bit repetitive, but we can either use p star or p. In our case, we're going to be using p star, just heads up. So if I simulate 100 million days and I set my sort of threshold to be p star, I'm gonna like end up getting some sort of average throughout those 10 million things that is going to be very close to the exact value. And the reason for that is because you're simulating all these days in the stock market, and so the variance as the number gets bigger gets closer to the exact value. And so what we want to do is we want to simulate one day that goes up, then another day that goes down, and so on and so forth. So what would that look like? So it would look a lot like what we did in the first part. And so let's make a quick function called, I'm gonna call this up or down. And our up or down, so again, if you haven't watched problem 1, I cannot emphasize it enough. Please go watch it, otherwise you'll be very confused. But our up or down is going to take in a couple of things. So because we're deciding if it's up or down, we are gonna take in U and we're gonna take in D. But we also have to take in our P, because our P is what's gonna decide if we are going to go up or down. So we are gonna take P star. And so now what the heck do we do with that? So similar to what we had with our Bernoulli problem, right? We are going to make some random number. So we want to import random, and then after we do that, make a random number, right? And once we've set that up, we basically want to say if U is less than or equal to our P star, then we're going to say that that's going to be going up. And so there's like a more in-depth explanation about this in the videos, and I think watching the videos, you should watch the videos, all of them, because I think they're very necessary for understanding this. But basically, if our U, which is our up value, is less than our P star, then we are going to go up. Otherwise, we are gonna go down. And so what up or down should give us is basically, am I going to go up in this day of the stock market, or am I going to go down in this specific day of the stock market? And yeah, that's basically why we need this like up or down function. So after we do that, then comes the actual part of calculating these states. So now, what we're going to do here is we want to make a second function that is going to calculate, I'm going to call it a path. Again, there are better names that you can give this, but this is just for like my purposes of teaching you all. So we are going to calculate the path of a stock. And so what we want to do now is we want this function to give us the prices of the stock from day 0 to 10. And so why do I want this to give me the prices from stock? Why do I want this to give us the prices of the stock from day 0 to 10? So you have probably not read problem 3 or 4, but if we have a function that gives us the stocks from 0 to 10, that will be very, very useful for problem 3 and 4. So I am going to make something that returns, I'm going to comment this out, returns a list of stock prices, so S of n, right? Returns a list of stock prices for every day from n to t, from 0 to t. So basically, let's say my stock price was going up $1 every day. The way that it's going to look is my initial price is going to be $1, and then the first day after that would be $2, $3, $4, $5, so on and so forth. You get my point. So I called it calculate path because I want to think about it as like my path from the stock price at 0 to all the way stock price at 10. And so, yeah, there's a bet. You could definitely give it a better name. It's up to you all. We didn't give you all headers, so whatever you want to call it, you can call it like stock prices from 0 to t, whatever you want to call it, up to you. But the idea is that I want to basically make a list of all the stock prices at every single day. And so what are we going to pass into here? So as a default, honestly, it might be good just to copy all the same parameters and paste them in there. You will probably not use all of them, but I think the flexibility is nice. So I'm just gonna like start you off with the idea of it, and then that's gonna be all up to you all. So we know what the stock price, right, at day 0 is going to be. So at day 0, the stock price is just going to be S at 0, oops, which again is a parameter that we pass in that is 50. And then after that, my stock price is going to be determined based on if my stock price goes up or down, which will be determined by our up or down function. And so this up and down stuff is going to be randomized. So sometimes we might get up, sometimes we might get down, but you are going to get so for example, if I want to get the stock price at day 1, I'm going to do S of 0 times either my up or my down is equal to S of 1, and so on and so forth. So you want to do that with every single one of them, and you want to add all these into some sort of list to take care of that. I feel like I have already given more than I had to away for this specific part, so we are going to keep moving. But yeah, that's like the general idea of it. And yeah, let's keep going. So after we have calculated our path, this is where like the Monte Carlo part comes into play. So these things are going to give us our like stock prices from 0 from the first day all the way to the last day. Again, I just like want to put it out there. You may have done this differently by the time you're watching this video. That is absolutely fine. I am just giving you all like one way to think about it, but there are like 50 other ways to think about it. So if you did it differently, this doesn't have to be the structure of your code. This is just like the structure that I would recommend because we're able to use calculate path for other parts and other problems in here. So yeah, now our Monte Carlo part comes into play. So we're gonna call our definition, again, you can call it anything you want. I'm gonna call it Monte Carlo. And so our Monte Carlo function is gonna take in, again, all the parameters. You may not use all of them. I can guarantee you like I'm right now just copying all the parameters just so that you can like get started on this, but that is going to be up to you to figure out what parameters you need and what parameters you don't. If you don't need them, make sure you delete them because we don't want to see you all with like 10 extra parameters that you don't need. So now our Monte Carlo simulation, again, the Monte Carlo simulation basically says that using this like part of like randomness, if the number is big enough, we can get really, really close to the exact value, which our exact value is calculated by our part 1. Recall. Okay, so now that we've done that, we basically want to calculate our payoff for n days. So what that means is that we are going to be run our path n times, and then we are going to get our payoff from that. So our function, if you do it this way, is going to give us a list of things, right? Or that's like what we had planned out. So if you get the last value of it, that's going to be the last value at S of n. So basically where we can get that is here. So we basically want to calculate our payoff at time t. And so we are going to have to use our function that we just made to grab the stock price at time t. And then we're going to subtract it by k. Again, we have another plus sign thing. So this again says if the number is not positive, I do not want it. I will just do 0 instead. If the number is positive, then give it to me, right? So what we're going to do is we're going to calculate n. We're going to run our path n times and get n CTs, which is payoffs at time t. And so now that I have like all these CTs, so I should give you n number of CTs, I want to basically get the average of them, and then at the very end I would return C of O. And so I would just multiply times the discount rate. So I think for this problem I should probably stop here because I've talked a lot, and I don't want to get too much away, but like the coding part is up to you all, but that is like the general idea of it. So yeah, thanks for listening, and go check out the videos for problem 3 and 4 as well. Bye.